project, from constructing an interstate highway to cleaning an existing highway drainage system. Erosion and sedimentation control is important. Not only does effective erosion and sedimentation control improve working conditions in the construction area, it prevents degradation of our precious water resources and personal property. Although erosion as a natural process sometimes is beneficial to man, accelerated erosion is usually detrimental. Accelerated erosion is the removal of land surface by man and natural forces such as wind and rain at a rate greater than would naturally occur. During the construction of a highway project, accelerated erosion usually begins during the clearing and grubbing phase, reaches its peak during the rough grading phase, and tapers off dramatically as slopes are stabilized with vegetation and the roadway subbase, structure foundations, and permanent drainage systems are in place. If proper erosion controls are not installed in disturbed areas before heavy rains, sheet erosion and ditch erosion, such as you see here, usually occur. In cases where highways have concentrated large flows of water and discharge them down the slope without any controls, erosion can cause severe damages to natural drainage channels and personal property. A byproduct of erosion is sediment, or matter, deposited by water. The accumulation of sediment is sedimentation. Project engineers, inspectors, and contractors have often asked the question, why is erosion and sedimentation control so important? Or is erosion and sedimentation control more important than constructing a smooth pavement or a structurally sound bridge? In seeking answers to these questions, you have to ask yourself, what happens if I don't do it? Erosion and sedimentation can cause an irretrievable loss of soil, destruction of fish and their habitats, degradation of water supplies, drainage problems and flooding, loss of industries dependent on clean water resources, and navigation problems. Some examples of the problems erosion and sedimentation create for us include clogging of drainage systems, need for frequent bridge cleaning, loss of fishing opportunities due to muddy water, need for dredging waterways and harbors, such as Baltimore Harbor, major decline of commercial fishing industries, such as the shellfish industry in the Chesapeake Bay, increased cost of treating water, the loss of swimming opportunities, and most important, the loss of soils, especially farmland soils, which took thousands of years to create. The problems created by erosion and sedimentation have long been recognized by Pennsylvania legislatures, conservationists, engineers, and contractors. Their efforts to avoid these problems have produced a comprehensive law, regulations, and procedures to control erosion and sedimentation on all earth-moving projects in Pennsylvania. The most important of these related to highway construction are the Clean Streams Law, Chapter 102, Erosion Control of the Department of Environmental Resources Regulations, PennDOT Design Manual and Standard Drawings, PennDOT Construction Specifications, DER Soil Erosion and Sedimentation Control Manual. It should be noted that the Clean Streams Law regulates pollution of any waters of the Commonwealth, including surface and groundwater, and penalties under this law range from a summary offense with a fine of $100 to $10,000 to a second-degree misdemeanor with a fine of $2,500 to $50,000. With this background, let's take a look at what the department has been doing the last several years to control erosion and sedimentation. As you already know, all PennDOT projects involving earth-moving activities have an approved erosion and sedimentation control plan, which is prepared in accordance with established design criteria and standards. These plans range in complexity from a simple 8.5 by 11 sketch plan with a brief narrative to a detailed set of 50 scale plans with a comprehensive narrative describing construction, staging, and other special measures. Do not start work until the erosion and sedimentation control plan schedules and operation methods have been approved by the County Conservation District. The contractor will submit an erosion and sedimentation control plan for all borrow and waste sites to the County Conservation District for their concurrence before work in these areas can proceed. With these plans in hand, the contractor schedules his operations and begins work. The most effective erosion and sediment control measure the contractor has at his disposal is the time he exposes soil to the weather. The quicker he can move the earth to where it has to go and stabilizes it, the less potential there is for erosion. The next most effective measure is the construction of temporary diversion drainage channels, which control the flow of water through the project area. As shown here, a top-of-cut ditch was used to keep the water from flowing down across the slope and eroding it. In this example, an impermeable fence was used to channel the water away from the slope. Another effective measure is seeding and mulching. As shown here, permanent hydro seeding is taking place on a cut slope, which will look like this, or this. Temporary seeding of fill slopes and topsoil stockpiles is also effective in protecting a slope or a stockpile until they are finished or used later. If an area cannot be seeded or mulched due to working conditions, a sheep's foot roller can be put to use in creating small pockets to puddle the water and dissipate some of its erosive forces. Knowing that sheet flows and concentrated flows are going to occur in a project area, regardless of the effectiveness of the measure mentioned above, flow velocity checks and filters are often installed. One of the cheapest and most effective of these measures is the natural vegetative barrier, which can be used on a slope to slow down runoff and filter it before it reaches a stream. Other measures which require installation and in most cases more maintenance are rock barriers, straw bale barriers, filter fabric silt fences, for slowing down and filtering more concentrated flows in ditches, check dams constructed of straw bales and filter fabric are used. Protecting inlets during construction saves cleanup time and manpower. Devices currently being used to protect inlets include straw bale barriers, metal standpipes, silt fence barriers, inlet stand boxes, and rock check dams. Due to the ponding effect these devices have, they also help to settle out larger sediment particles. If permanent diversion and drainage channels are planned for the project, they can be installed early and used to carry water through the project area. Several types of materials have been used successfully to line these permanent measures. Here we see the use of large rock to line a top-of-cut ditch, or the use of rock to line a permanent drainage channel, or the use of gabions, or half-round pipe, or concrete lining for the same purpose. For permanent swale protection in median and recovery areas, jute matting and nylon erosion control matting have been used successfully in combination with seeding and mulching. We would like to emphasize that measures such as these are used on 3R type projects as well as major earth-moving projects. Probably the most effective of all sediment control devices are sedimentation basins. Although they are effective, they are also the most costly to build and risky to operate. They should be viewed only as the last chance to capture sediment before it leaves the project area, not a cure-all. Sedimentation basins come in all shapes and sizes. The larger the drainage area, the larger the sedimentation basin. Also, the smaller the soil particles to be settled out, the larger the basin should be to provide adequate detention time. Examples of temporary basins include these small expedient basins, which require little or no engineering work, and these larger basins, which were designed in accordance with the department's RC 70 standards. Here we see permanent basins which will function as stormwater management measures during and after construction. This permanent basin was turned over to an adjacent property owner after the highway construction was completed. Now it serves as a recreational lake. Slowing water down or dissipating its energy as it moves through the project area is an important function of energy dissipators. Without them, natural and man-made drainage facilities downstream, which were not suited for high-velocity flows, experience strong erosive forces and usually fail. Their failure caused channel scouring, bank failures, flash flooding, and unwanted deposition of sediment in drainage systems and on private properties. Examples of energy dissipators include dumped rock in ditches, concrete blocks in paved channels, dumped rock at pipe outlets, cast-in-place head walls, hydraulic drops, and standpipes. Roadway and bridge projects often require the alteration of natural stream channels or creation of new stream channels. In order to minimize the adverse erosion and sedimentation effects in these modified channels or new channels, it is often necessary to stabilize or armor the stream banks with non-erodible materials such as rock or gabion baskets. With the rock in place, it is seeded and mulched and eventually will look like this. Or this. The goal of every stream relocation project should be to encourage the return of a stream to its natural condition as soon as possible. We hope that concrete-lined channels and gabion-lined channels like this one are a thing of the past. They make it almost impossible for a stream to recover. As most of you know, the department is in the midst of completing gaps in its urban interstate system and the Appalachia highway systems, replacing, rehabilitating, or reconstructing a large number of bridges and rehabilitating major sections of its interstate and primary highway system. With these highway and bridge improvements comes the necessity to cross streams or work in streams. Now, we can't cross a stream like we used to. We now use causeways. With the current emphasis on erosion control and the tendency to use sediment-producing material for causeways, we have revised our specifications for causeway material to include only rock larger than 3 inches in diameter. Examples of temporary stream crossings and causeways include this log crossing, this temporary pipe with rock backfill, this pair of pipes with rock backfill, these multiple pipes with rock backfill, on this project, a portion of the causeway was constructed with an excess of fine material, and measures were taken to ensure that the balance of the causeway is constructed of rock at least 3 inches in diameter. Cofferdams are widely used devices for constructing new bridge piers and abutments and repairing old ones. As seen in this picture, an earth cofferdam has been used to construct this bridge pier. This sediment-producing material is not acceptable. There will be a special provision in all future contracts to prohibit the use of sediment-producing materials for cofferdams. Example of cofferdams constructed of both rock and earth include this one and this one. Dewatering of structure foundations often result in the discharge of the muddy water directly into a stream. This practice is in violation of the Clean Streams Law. Only clean water, as shown in this slide, should be pumped or allowed to flow into a stream. If the water is not clean, it should be pumped from the foundation areas into a sedimentation device such as a sediment basin. Here is another example of how muddy water from the foundation excavation was retained in the settling basin and discharged into the stream as clean water. It should be emphasized here that the sedimentation basin needs to be properly sized to effectively remove the sediment from the volume of water anticipated. A smaller basin may be used in combination with filter fabric if space to build a properly sized basin is not available. We have presented these basic concepts of erosion and sedimentation control for highway construction to give you a better understanding of what can be done to build a better highway and a better environment.